Welcome to the Identity in ASP.NET Web API tutorial. In this video, we'll dive into the essentials of integrating authentication and authorization to secure your Web API. First, we'll explore how to set up and configure identity in your ASP.NET project. You'll learn how to manage user accounts, roles, and claims with the identity package to ensure that your API knows who's using it. Next, we'll walk through the process of authentication, explaining how to implement a token-based authentication to verify users and keep your application secure. Then we'll cover authorization, detailing on how to control what different users can and cannot do within your API. We'll demonstrate how to use policies and role-based authorization to enforce your security rules effectively. By the end of this video, you'll have a solid understanding of how to protect your API application using identity, ensuring that only the right users have access to the right resources. This tutorial is part of a full-length Web API video course designed to give you a comprehensive knowledge and practical skills in ASP.NET Web API development using clean architecture, secure and Azure services. You can find the link to this video course in the description. If you are new to the channel, make sure to subscribe. If our application in its current state would be made available to the internet, anyone who knows the IP address at which it will be hosted could send a request to our API without any restrictions, and we wouldn't even know what user sent which request. If you want to know the identity of a user using our application, we must introduce the authentication mechanism of our users. Authentication is the process of confirming the declared identity of the entity involved in the communication process. The purpose of authentication is to obtain a certain level of confidence that a given entity is in fact the one that it claims to be. Once the user is authenticated, we know who the user is. Authentication is a fairly general concept that refers to many areas in our lives, and depending on the communication channel, different methods and authentication protocols are used. For example, for paper documents, it may be a signature, seal, or a watermark which gives the document its authenticity. In the case of verification, the identity of a person, for example when entering a building, verification is carried out by using some identity documents, PIN code, or some electric cards. And when it comes to the authentication in electric communication, for example to open some program or to use a web application, in this context, methods based on proof of having a password or some private key or a one-time token are used. The authentication processes themselves can be divided into three categories. The first one is something you know. Here, the authentication method will be to provide, for example, a password, a PIN code, or an answer to a security question. The second category is something you have. For example, it can be a token, some card, or a cell phone with a software installed on it to which one-time password will be sent. The last category is something we are, which is a self-authentication mechanism. You can be authenticated using your fingerprints, voice commands, or by a face recognition. To increase the security in applications that contain sensitive data, for example, for bank transfers, two-factor authentication is often used. This is why the most internet banks use this type of authentication. For example, by entering the code that is sent to the number of a user who tries to log into his account, just right after entering their passwords to confirm their identity. So here, the second component is something that the user has. In this case, is the text code, and the first component was something the user knew, which in this case was the password for his account. When it comes to our application, we'll need to add user authentication using the account name and password, so it will be something that the user will know. However, before we'll start adding authentication to our application, we must prepare the appropriate infrastructure, namely the tables that will store the information about the users. Then the API methods for registering users, and also a method or an endpoint to actually provide some kind of a token for the API client with which the API client can be authenticated with. And this is what we'll deal with in the next lessons using Identity Framework. Before we'll set up authentication mechanism in our web API, we have to configure some kind of identity system that's going to store the user data, like their email addresses, password hashes, etc. For that, you can configure some external identity provider, like Facebook, Google, or Microsoft, or we could just even build our own from scratch by defining tables in our database to store the user information, on top of which we would have to create some endpoints that would register the user, allow them to log in, which in the context of web application is going to be using access token in the header of authenticated request. But instead of that, we can also make use of the ASP.NET Core Identity package, which was built by Microsoft just for this purpose. Once we configure it, we'll be able to set up authentication and then authorization mechanism through our web API. And also, this package will provide features like registering the user, logging in, resetting password, and few more which will be exposed as endpoints in our web API available to the end client. Before we will jump into the code, let's briefly discuss how does the identity package work in general. First things first, identity package relies on Entity Framework Core. So without it, we wouldn't be able to use identity package. We would have to set up it ourselves from scratch by creating the tables in the database, with also the endpoints that would register the user, allow them to log in, or for example, reset the password. But the identity package is going to extend our web API project with some classes to implement the identity. And the base class, the very class that is going to represent the user definition in our database and also in the code, is going to be the identity user class, which is going to store the basic information for a given user. So properties like ID, username, email, information whether the email is confirmed, his password hash, phone number, and some other properties will automatically be by default possible to initialize on the user object. Next to that, also as a base class, we'll have the identity role class, which will define what roles the user is in. So role is basically a key value pair for its ID and the name as the role definition. With those base classes, the identity package will then also offer a class that is going to represent the identity DB context, with which we can extend our own DB context, and this will provide few DB sets, which are going to represent the properties for users tables, for the roles tables, and also for the mapping between the user and roles, and also some other DB set properties to define the tables for claims and also the connection from role to claim. Then on top of that, identity package will also provide us the iUserStore interface with its concrete implementation that is going to actually represent some kind of a repository for this identity user storage. So with this class, we are going to be able to actually create the users, we'll be able to delete them from the database, update their passwords, their email address. Every operation that is going to somehow manage the user on the database level is going to be possible through this iUserStore interface. And this interface is going to be actually used by the user manager, which is a service class that's going to actually create the user's entities. For example, by hashing their passwords first of all, and then saving them to the database. It will also define some methods with which you can find the user by his email, by his ID, by his login. With that manager or this service class, we also will be able to update the user details and even remove him from the application. Lastly, on the very outer edge of this identity package, we'll have some endpoints that are going to expose the features like user register, user login, user password reset, etc. So here, identity package is going to rely on the minimal API feature from the ASP.care framework. So these are not going to be controllers in our code, but a simple endpoint, for example, to register the user by using the user manager class that we have previously just seen. So the endpoint is going to capture the incoming HTTP request, it's going to use the user manager to register the user, and also it's going to return an appropriate HTTP response back to our API client. So with that in mind, maybe let's take a look at the identity package hierarchy from a different perspective. So on the very bottom of the hierarchy, we have the identity user class. So this class is going to represent the user of our application. And if we would like to define our own user properties, we'll have to create a class that's going to inherit from the identity user, which then can be extended by some properties of our own. So for example, if you wanted to actually add a date of birth property or a nationality property to our application user, we'll have to create a class that's going to inherit from the identity user, which we will then extend with those two properties. Then on top of the identity user, there's this identity DB context abstraction that is going to extend our DB context by defining few DB sets, which are then going to be mapped to the tables in our SQL database with the user definition, with the role definition, and also the connection between the users and roles. And to manage the users on the DB context level, identity package also exposes the user-store interface that's going to insert, update, or in any form manage the users by providing this repository interface called as user-store. This user-store will be used actually by the user manager class to handle the application logic, like for example, hashing the user password whenever we want to register the user or update his password, and then use the user-store to actually update the database entities for the user identity object. Lastly, on the very top, to actually use those features by our API clients, identity package is going to expose some endpoints with which we'll be able to register the user, get the access token, so login the user to our application, reset his password, and many more. So here, as you can see, the dependencies go down from the outer layer, which are the endpoints, down to the identity user class, which is going to be the very base class when it comes to identity package. Alright, so having that in mind, let's go back to our code and try to add the identity package to our solution so that we should be able to actually create users in our database by the exposed endpoints from identity package. So first of all, we'll have to install the identity package, which is obviously going to be connected to the infrastructure, but as we are going to define our own custom user type, which then we would like to, for example, connect to a restaurant model, just because of that, I will have to install the package here in the domain module. So let me right click on this module, go to the NuGet package manager, and in the browse section, I'll just look for the package called Microsoft ASP.NET Core Identity.Entity Framework Core package. So this is going to be the package which will extend our API features by providing the identity context. So let's go ahead and install that to the domain module. And after a while, maybe let's first of all define our own user type here in the entities folder. So maybe I'll just add a new class, user, and as you already know, this class will have to inherit from the identity user type. So let me just quickly add this identity user as the base class for our user type. Right now, instead of relying on the identity user, we'll have to rely on the user type, which we'll later on extend with our own properties. And on this class, we'll have to rely whenever we are going to refer to the identity package. So for example, let's go ahead and then adjust our DB context so that now, instead of just inheriting from the base class of DB context, it will inherit from identity DB context, for which I'll have to add the using namespace. And this DB context also takes generic parameter defining the user type for the identity user. In our case, as we just had defined our own user definition, I'll have to provide this user as a generic parameter to the identity DB context. Now, to register the interfaces for the iUser store and also the iUser manager types, we'll have to add some services to the dependency injection container. So in our add infrastructure extension method on the services collection, I can just invoke the add identity API endpoints method, which is going to take a generic parameter of our identity user definition, for which I'll have to add the namespace. And then also on top of that, I'll have to invoke the method add entity framework stores for our DB context. So let me just get the restaurant's DB context name and pass it here as a generic parameter. So with this simple 2 lines of code, the ASP.NET Core identity package is going to register the entity framework stores, which are basically repositories for user roles and also some other types. And at the same time, with the add identity API endpoints, we are going to register some concrete classes that are necessary for the identity endpoints, which are we going to add in a second. Now to add the endpoints to our API, let's go to the program CS, because here we'll have to use a middleware. Namely, it's going to be a method called map identity API, which also is going to take a generic parameter of the identity user, which in our case is just a user type. With this simple change to our API, now it should expose a few endpoints to register the user, to login, which is going to generate an access token, to reset his password, etc. But before we start our application, we'll have to create a migration since we have extended our DB context with the identity tables. So let's go ahead to Tools, NuGet Package Manager and Package Manager Console. And here I'll just specify that I want to add a new migration. Let's call it identity added. And after a while, there's a migration created with few tables like ASP.NET roles, ASP.NET users, ASP.NET role claims, and few others, which now we'll have to apply by the update database command. So once again, let's go to the Package Manager console, and this time let's type update database. And as we already know, this command is going to actually apply, so update the database with the table's definitions. Alright, as you can see, it went smoothly. Now we should be able to start our Web API program and set the sample request to the register endpoint. Let's start the application and open our API client. And here on the very bottom, I'll just create the new HTTP request that's going to respond to the HTTP post verb. And by default, the endpoints provided by the identity package don't have any prefix to them, So to register a user, I'll just have to invoke the /register endpoint, and as a content type, I'll just specify application/JSON, and in the body of this request, I'll have to specify the email address and the user password. So let's say that the email is going to be testuser@test.com, and the password, well, let's first of all try some very simple password. And with this request, I'm going to get some validation errors specifying that the password must have at least one non-alphanumeric characters, one digit, and one uppercase character. So let's go ahead and adjust the password with one uppercase character, one digit, and also some non-alphanumeric character. And this time, with a valid password, we're going to get 200 OK, and this means that our API user has been registered. And to log in to this user, I can once again send a request, but this time to the login endpoint, providing his email and a password in the HTTP request body. So for that user, as you can see, we are getting a 200 OK response with the access token, the token type as bearer, and also a refresh token, and the expires in property for this access token. Later on, we'll see how can we use this access token to actually authorize as this test user. But for now, let's maybe check what will happen if I will provide incorrect password for this test user. Then in that case, as you can see, the identity package is going to just return 401 unauthorized response back to our client. Maybe let's go ahead for a second and open the database, because here if I would check what tables have been created, as you can see, there's plenty of new tables in our database, namely ASP.NET roles, users, user tokens, user roles, user logins, and role claims. Let's take a look if our newly created user is actually in the ASP.NET users table, and if I execute the select statement, as you can see, we have one user created for which the username, his email, his password hash, and also some other properties are inserted to this table. So this is how, with just a bit of configuration for the identity package, we are able to actually provide the identity infrastructure to our database and also the endpoints so that the API clients can register their accounts, can log in, can register their passwords, and many more. With the map identity API method, we have added few endpoints to our API, but if you would run the web application and then open Swagger page in the browser, as you can see, there is no information about the identity endpoints whatsoever. We still have our dishes endpoints and our restaurants endpoints, but there are no endpoints visible to register the user or to log in, and we already know that they exist in our API since previously we have just invoked two endpoints to register the user and also to get the access token. And why is that? Well, by default, Swagger documentation doesn't support the minimal API approach, which was used by identity package to expose those few endpoints. Now, in order to fix that, I will have to add a bit of configuration here in the program CS class. First of all, on the builder services collection, I will have to add also the invocation of add endpoints API explorer, and this should also include every minimal endpoint from our API through a Swagger interface. Right now, if I would start the application once again and go back to the Swagger page and refresh it, here on the very bottom, as you can see, we have plenty of endpoints that are available through the identity package. So again, we can just invoke the register method with the email and password. We can try to log in with some additional options, like for example, do we want to store the access token in the cookie or not? And also there are a few endpoints to refresh the token, confirm the email address, resend configuration email, endpoints to get the password or to reset it, and manage the account info. Okay, but let's assume that some of the endpoints will require authentication. Like for example, trying to update my own account, I will have to actually provide the information about the access token in form of a header through the API request. And currently, there is no way to provide this access token in any form through this Swagger interface. To fix this issue, let's go back again to our API program and also add a bit of configuration that will add the security definition for the bearer token in Swagger documentation. To do that, we'll have to extend the add SwaggerGen method by providing a configuration object, and on this configuration options object, I can now invoke methods, like for example, add security definition that is going to allow the Swagger clients to define a security header in the context of Swagger session. To this method, as the first parameter, I'm going to pass a name, and maybe let's call this definition as just better out. And as the second parameter, I will have to specify a new OpenAPI security scheme, which is in the Microsoft OpenAPI models namespace. And on this object, we'll have to define at least two properties. The first one is going to be the type, which is an enum value for the security scheme type, with options like API key, HTTP, OAuth2, or OpenID Connect. In our case, as we are going to use the bearer token authorization header, I will just select the HTTP option. Lastly, to this object, I will also have to specify the scheme, which in our case is going to be the bearer scheme, as we are going to use the default authentication through a bearer access token. And right now with this bit of configuration for a Swagger documentation, if I would refresh the page, here on the very top right corner, we have this new button, which is called Authorized. And if I would click on that, we'll be able to actually provide the access token in this value field and then click Authorize. Once I'm authorized, it doesn't necessarily mean that the token is valid, but it's rather information for a Swagger that we are trying to store some kind of an access token in its memory, and then we should be able to use it in the follow-up requests. So with this fake token in memory, if I would try to, for example, execute this /API/restaurants endpoint, well, then in the CURL, you can see that this token has not been added to the request. Even though we are storing it, and in theory we are authorized through Swagger, the token is not being added to the request. And this is because we also need a bit of configuration that will actually inject the provided token to each and every request executed by the Swagger interface. So once again, I'll stop the application, and also in the Swagger gen method, this time on the optionals object, I'll just invoke add security requirement. That's going to take an open API security requirement object as its one and only parameter. And if we take a look at the definition of this object, then we will find out that this is a dictionary of OpenAPI security scheme and also a list of string values as a key value pair. And if you would read the description, it says that each name must correspond to a security scheme which is declared in to the security schemes under the components object. And also, if the security scheme is the type of OAuth2 or OpenID Connect, then the value for a list of scope names is required for the execution. For other security scheme types, the array must be empty. This means that in our case, as we are not using OAuth2 or OpenID Connect, then we'll just provide this second parameter as an empty array. With that in mind, let's go back and actually provide this key value pair to this dictionary. And here as a key, I'll just specify a new OpenAPI security scheme object, with which we are going to just reference our definition, which we have configured previously through the add security definition. So as a reference on this API security scheme, I can just create a new object, which is OpenAPI reference. And here we have to specify that the type is indeed the reference type security scheme. And to connect this scheme to our definition that we have previously created, we'll have to just pass the same ID or the name of the scheme that we have previously created. So by saying that we are going to add bearer auth security scheme, Swagger UI will know that the bearer token will be used in the request executed through the Swagger UI. And then as the value, I'll just provide an empty array of strings in form of empty collection expression. Finally, if I start the application once again and open Swagger page, once I have refreshed the page, I can once again click on the Authorize button, provide some fake token, click Authorize, and this time, if I would execute the /API/restaurant method, now you can see that there is a header called Authorization with a bearer indication and the value of our token that we have inserted through the Swagger interface. And this is how we'll be able to actually authorize our request to a Swagger interface by providing a valid access token to this Authorize Swagger pop-up. Maybe also let me show you how to actually change the prefix of this identity endpoints URL, as it is a good practice to actually stick to a naming convention for our API endpoints. So let's go back to the project, and before the map identity API method, I can just invoke the map group that is going to define a prefix for every endpoint coming through the map identity API route builder object. So here, let's specify that the prefix should be API/identity like this. With this simple change, going again back to our Swagger page, this time after refreshing, we see that indeed all of the identity endpoints have now the prefix of /API/identity. We have configured Swagger to support the identity endpoints as well as enabling users to insert their access tokens via the user interface. But with that, our section in the program CS, in which we are configuring the services, grew and created a bit of chaos. We've already extracted the services from the application and the infrastructure modules. Why don't we do the same for the presentation layer to clean up this mess? For that purpose, I'm going to create a new extension method, but this time, instead of doing this on the iService collection type, I will do it directly on the web application builder, since we are using the host property to set up the serial lock. Alright, so let's go ahead and create a new folder for the extensions in our API project. And inside I will just create a class called web application builder extensions. So first of all, let's make this a file scope namespace. And also I will mark this class as a static one. And here I'll just define a public static class with a void as a return type. And let's call it just add presentation. And as we are going to create an extension method on the web application builder type, with this keyword, I'll just define one parameter and let's call it builder. Alright, so maybe let me open the program CS file. Now I'll just cut the services that we are registering for the presentation module. So stuff like add controllers, add Swagger gen, adding the services for our middlewares. And lastly, the use serial log extension method on the host property. So right now, in the program CS, we'll have to now refer to the add presentation extension method by just builder.addPresentation, for which I'll have to also import the restaurants.api.extensions namespace. With that in place, maybe let's also clean up the now unused namespaces from this file. We should be able to run the web API and it should work as previously did. As you can see, the Swagger UI page is working properly. So maybe just to test it, I will invoke the /API/restaurants endpoint. And as we are getting the results in our HTTP response, we can assume that the refactor that we just did is working properly. The identity infrastructure is properly set up and we have successfully exposed the identity endpoints through our web API. Now let's take a look at the next crucial step on our ASP.NET Core journey, which is the enabling of user authentication. Authentication is the cornerstone of a secure and reliable web application. It ensures that users accessing our systems are who they claim to be, providing a safeguard against unauthorized access and potential security threats. If we look at program CS, by default a new web API will have this authorization middleware added by invoking the app.useAuthorizations. And this is the first step to actually enable authorization to our web API. The next one is going to be adding some services needed for the authorization mechanism. And to add them, I'll just go ahead to our new web application builder extension. And here, again on the builder services collection, I'll just invoke add authentication. And now with that services added to our web API, we should be able to run the application, get the token for an existing user, and then use this token in a form of header as a bearer token for any HTTP request. So let's go ahead and start the application. Let's go to our API client, and here first of all, I'll just get a new access token by just sending the post request to the login endpoint. But as we have extended the path to this endpoint, I'll also include the prefix of /API/identity, and maybe also I will do the same for the register endpoint. So just add the /API/identity prefixes to both of them. Okay, so let's go ahead and send a request to get the access token for the test user by sending his email and his password. In the response of this request, I will just copy the access token property. And since we are going to use the API client inside Visual Studio, I'm just going to store this value in some sort of variable. So maybe here on the top, I'll just define a new variable. Let's call it token. And I'll just paste the access token that was returned from the login endpoint. Now to authenticate to any request, I'll have to send this token as a value in a bearer authorization header. So let me show you how to do that. Let's assume that I would like to authenticate to the /API/restaurants endpoint. And for this request, I'm just going to add the authorization header with the value of bearer and then the token from our variable. Maybe let's also go ahead and add the breakpoint here in the getAll method so that we will see what's the difference with and without the authorization header for such request. Let's hit the send request button. And as always, we are going to hit the breakpoint inside of our getAll method inside of the controller. But this time, if I would open the quick watch for a debugger, I will be able to actually look up the property that's defined on the controller base class. And this property is just called user. And on that property, as you can see, there's one identity. So maybe let's expand it. And there are some values collected as claims for this identity. And there's 5 of them. So if I expand the claims property, we have the value of the user ID for a claim with a specific name or type. There's also a claim that defines the email address, which is going to be the same value as the username. And there are a few other claims, like ASP.NET Identity Security Stamp. But with that information, we should be able to actually authenticate the user that sent a request to our API by this user property for any controller. So we know how to authenticate any request coming to our API by using the authorization header inside of a request from the API client. But how can we actually enforce authentication so that only authenticated users are going to be able to actually execute the given endpoint? Well, we can do it with some dedicated attributes that you can set on the action inside of our controller. So let's imagine that the getAll method should be only available to the authenticated users. To do that, I'll have to put a new attribute, which name is authorize. And with this simple definition, only the users who have a valid access token in form of a request header are going to be able to actually get into this endpoint and see its results. So let's run the web API once again and try sending 2 times the same request, but 1 time with and the second time without the bearer token in the request header. First of all, if I will send the request with the bearer token as a header, then as you can see, I'm able to actually get the restaurants and retrieve it back to our API client. But if I would do the same, but now without the authorization headers, which I have just commented out, then this time I'm going to get 401 unauthorized error message back to the API client. So with this simple attribute that we have just put on the controller action level, we'll be able to specify that a given action is only available to the authenticated users sending requests to the API. The same authorized attribute can be used on the whole controller level. So let me just copy and paste it on the controller level. This will mean that every action inside of our controller will now require authentication of our incoming HTTP request. So with that in mind, if I would run the application once again, now not only the get all restaurants endpoint will need authentication. So if I do it without the request again, I'm going to get 401 unauthorized, but with the authorization header, I'm still able to execute this endpoint. But since we are having this authorized attribute on the controller level, now for example, the getById endpoint will also require the authentication of our API clients. So let's send a request to the getById endpoint without the authorization header. And indeed, I'm getting the 401 unauthorized response back to the API client. So this is how with the authorized attribute, I was able to actually specify that a given action or the whole controller, which means that every action inside of it, will require the authentication of the users sending requests to this controller. But let's assume that there is only one endpoint that should be available publicly, so for any users without the access token as the bearer value. Let's assume that this endpoint is going to be the getAll inside of the restaurants controller. Well, I could obviously just apply the authorized attribute on every other action inside of this controller, but as we have plenty of them, it might be hard to maintain later on in the project development. So instead of it, there's actually one more attribute that is going to enable the anonymous access for a given endpoint, which I can apply directly on the action itself, and the attribute is called allowAnonymous. Now with both authorized attribute applied on the controller level, but also with the allowAnonymous on the action level, every endpoint besides this one will require authentication of the request coming to this controller. To find out, let's also run the web API. And once again, if I will send a request to the endpoint which requires authentication, I'm going to get 401 unauthorized. But this time, if I will send a request to the getAll endpoint without the access token, as it is applied with the allowAnonymous attribute, I'm going to get the response back from our API server. But for any other endpoint inside of the restaurants controller, I will have to include the bearer token as authorization header, and only then I should be able to actually get the correct response from a given endpoint. So this is how the authorized attribute will be able to enforce authentication of users for our API. We have seen that for authenticated requests, the user property on any controller will be filled with the information about the currently logged in user as a claims principal object. Having this information on the controller level, how do we pass it down to the application layer so that some of the handlers we already have for queries or comments know about the user? Well, we could define a dedicated property for the user ID or username in every comment or every query that would need this information and then pass it down from the controller like this. So in some action, I would have to specify a variable for the user ID value and then just use the user property that is available on any controller, on which I will have to refer to the claims property, and then using further default, I will have to specify some lambda that is going to take the value of a claim that contains the information about the user ID. So I can distinguish the claims by their types, and basically here I will have to replace the string with a correct type for the claim that contains the user ID information. And having that in the controller, I will also have to specify the user ID property in some kind of a comment, and then just pass it down through a constructor and initialize the field with the user ID value. But this approach is going to be a bit cumbersome, as with many queries and comments, we would have to apply the same logic for every query and also in every controller's action, from which we will need the user context information. So maybe instead of that, let's create some better, more flexible approach, which will enable us to actually get the user details or the user context in any place that we would like to get that information to. Let's just clean up the get restaurant query and also the get by ID action. And instead of that, first of all, I'll just create a dedicated folder for the user features in our application layer. So in the application module, I'll create a folder called user, and maybe inside, let's create a class that will contain the information about the claims of currently logged in user. I will call it just current user. I will remove the unnecessary namespaces and convert this file to a file scope namespace. And maybe instead of a class, I'll just create a public record current user that will first of all contain the information about the user ID, user email address, and also it would be good to actually have the information about the roles in which the user currently is assigned to. For now, we don't have roles defined in our system, but later on, we'll be adding roles to actually distinguish application administrators from standard application users. And as one user can have multiple roles, I'm going to create a property of type IEnumerable and a string value representing each role. So I'll just call it roles. And then lastly, maybe I'll just define a method that is going to define whether a given user is in a concrete role or not. So a public boolean, let's call it is in role. And here the role value as a string is going to be the parameter. And all I have to do is just check whether our property roles contains the role parameter passed down to this method. Okay, so we have a basic definition of the currently logged in user for our application with the standard claims values like ID, email, and the role definition. Now, how do I actually get the user claims principal and convert them to this current user type? Well, to do that, I will have to create some kind of a service, which is going to take the current HTTP context and also the claims property of the user on that context, then get the correct values and match them to our current user type. Let's go ahead and create a class, which I will call just user context, which is going to return a current user object from some method. So let's assume that there's going to be a public current user method. Let's call it get current user, in which I'll have to somehow refer to the HTTP request context. And to do that outside of any controller, we'll have to inject an object of type HTTP context accessor, which I'm going to just call HTTP context accessor. And with that object, now in our get current user method, I'm going to create a user variable into which I'm going to assign the HTTP current accessor, HTTP context user property. But here as the HTTP context might be a null value, I'm just going to add this null conditional operator. And with that, possibly, our user variable is going to be a null value. So if the HTTP context doesn't exist, or the user on the HTTP context is not present, our user here is going to be a null. And in that case, we are not going to return a current user object. So maybe I'll just check if the user is null. Then I'm just going to throw a new invalid operation, stating that the user context is not present. And this would mean that we are trying to get the user information in some place in which the user context doesn't exist for the current HTTP request. But the other case might be that the user actually exists in the HTTP context, but it is not properly authenticated. So I'll just create a separate if statement in which I'm going to check if the user identity is a null value or if the user identity is not authenticated. So in any of those two cases, if the user is basically not authenticated, in that case, I'm just going to return a null value from our getCurrentUser method. And as we are going to return a null value, we'll also have to apply the nullable type to our return type definition for the current user. After those two checks in those if statements, we are sure that the user exists in our HTTP context and he is properly authenticated, and you should be able to get the claims information and convert them to the current user type. So first of all, let's get the user ID value, for which I'll have to refer to the user, and here on the claims property, I could just find the claim with a given type, or I could just use the findFirst method, which, as you can see, retrieves the first claim with the specified claim type. So it's a shorthand. Instead of referring to the claims property, I can just get the claim directly. So here I'm going to specify a lambda that is going to indicate that the given type is going to be the value of claimTypes.nameIdentifier. This claimTypes class contains the information about various different claim definitions, which are the standard values in ASP.NET Core applications. So as you can see, here we have some values of the claim types for a name identifier, which will contain the information about the current user ID value, and also some other claim types, like for example, email address or the role definition. With that in mind, let's go back and just get the value of that claim by referring to the value property on the claim object. Similarly, I'm going to get the email address for a user from the claim which type is going to be just email on the claim types class. Lastly, let's also get the claims for the roles. And here, as user could have multiple roles, I'm not going to be able to use the findFirst, as we would like to get every role for a given user. So instead of that, I'll have to refer to the claims property, and then with the where method, I'm going to indicate that I would like to get all the claims that are defined as a claim type role, and instead of a single value, I'm going to select every value of those role claims. So with that, we have now three information about the user ID, user email, and also about the user roles. Let's just go ahead and return a new current user with the value of user ID, email, and the roles claim values. Now, having this user context class, it would be good to have some kind of an abstraction of this getCurrentUser method. So to do that, I'll just create an interface for the user context class with only one method definition, which is going to be the getCurrentUser. And now we'll have to register this service in our dependency injection container so that in any handler in the application module, we'll be able to actually refer to the current user context and get the user ID or the user email. So let's go to the extensions of the application module, and here in the addApplication method, I'm going to just invoke services.addScoped, and for the iUser context, I'm going to just register the user context concrete type definition. And then lastly, on the services collection, in order to get the proper implementation of the iHTTP context accessor object, I will have to also invoke the built-in method, which is addHTTP context accessor, which will allow us to inject the context accessor to our user context service class. With this definition, now we should be able to actually inject the user context to any handler in our application module, with which we are going to retrieve the user context information containing values for the user ID claim, email claim, and also the roles of a given user. In the next lessons, we'll see how can we utilize that in practice. We are using the identity package, which provided the base class called identityUser that's going to define the properties of our application user. There are some properties like username, email, password hash, even the user phone number. But what if we needed to extend this base user definition with some custom properties, like for example the user date of birth or his nationality? Well, to do that, as we have already created a custom user type definition that inherits from the base identity user type, we can now extend this user class with some custom properties that we would like to introduce to the identity user definition. Then with those properties, we'll have to also apply a migration to the database and also update the database itself so that new properties are reflected as columns in the user table. And lastly, as we are using the identity package, we'll have to make sure that in those three invocations, so in map identity API, and also on the add identity API endpoints, and then again on the identity DB context, we'll have to use our own custom user definition as a generic type, and this class has to inherit from the identity user type. With that in mind, let's go ahead and see how can we extend this user definition with those two properties of user date of birth and also his nationality. So let's first of all create a public property of type date only that's going to represent the date of birth value for a given user. And as we are going to introduce this property to an existing model, I will also make this a nullable value so that for users that already exist in our database, there will be no default value, but a null instead of that. Let's also create a second property in our user definition that's going to represent a nullable string for his nationality. Now with those two properties, as we have expanded our custom user definition, we'll have to add a migration that's going to extend also the database side with those two columns for the date of birth and also the nationality. So let's go to Tools, NuGet Package Manager and Package Manager Console. And in here, I'll have to make sure that I have selected the Restaurants Infrastructure module as the default project. And at the same time that the Restaurants API is the startup project in my solution. With that setup, I can go ahead and execute the following command. Add migration. Maybe let's just call it user additional properties added. And after a while, once the project is successfully built, the migration has been added to our project. So as you can see in this migration, we are going to add two new columns to the ASP.NET users table. First one is going to be date of birth as a nullable date, and the second one is going to be a string value for his nationality as an nvarchar max type of column. With this migration, now I can go ahead and execute it. So just by invoking the update database command, this migration is going to be applied on the database, extending our ASP.NET users table with those two new columns. Let's just check on the database side whether there are actually those two new columns on the ASP.NET users table. So if I would expand the column section, as you can see here on the very bottom, we have the date of birth and the nationality columns added to the ASP.NET users table. But now there is actually no way for the users to update those properties. And for that, we'll have to create our own custom endpoint that's going to update the properties of a given user. And as currently, in our API, we only have two controllers, one for the dishes and the second one for the restaurants. I have to create a separate controller for the identity purposes. So let me just create a new controller. I will just call it identity controller. And here again, let's make it a file scope namespace. I'll add the API controller attribute to this controller and also the route attribute with the template path API/identity. And in this controller, let's define an action that's going to update those two properties for a currently logged in user. To define such action, let's maybe create a public asynchronous method that's going to return a task of iActionResult. Maybe let's call it update user details. And for the path to this action, I'm going to apply the HTTP patch attribute with the path user like this. And now you might wonder whether we actually need the user ID so that we know to which user we want to apply the property changes for. The answer is yes, we'll need the user ID, but you can get it from the HTTP context of the send request by the API client. So instead of hard coding the ID into the request path, I'm going to get it from the HTTP request object. So for that endpoint, maybe let's go ahead to our application module and create an additional command that's going to actually update those two properties for the user date of birth and also his nationality. So in the application module, I'm going to create a new folder in our user folder. Let's call it just commands. And inside I will create a class update user details command. So with that command, I'll have to store the information about the user date of birth and again about his nationality. So let's just define those two properties. First one for the date only as a nullable value. Let's call it date of birth. And also a nullable string as his nationality. And as this command is going to be used by the mediator package, I'll have to apply the iRequest interface to this class so that now we can create a handler that's going to do the actual updating of the user details. So in the same folder, I'm just going to create a user update details command handler class. And as we already know, this class will have to implement the iRequest handler interface for update user details command type. So let's go ahead and implement this handle method. And in here, maybe let's first of all inject the iLogger interface to this class so that we can have some traces whenever user updates his own account. So with the logger interface, I'm just going to log information, updating user, and then I'm going to need some user ID value. With the request and with the add sign, the servlog is going to actually serialize our request object. But how can we actually get the user ID value? Well, previously we have created our own user context class that can retrieve the user identity from the HTTP context accessor object. So relying on the user context interface, I should be now able to inject it to our update user details command handler. And with that object, maybe for some variable called user, I'm just going to invoke the user context dot get current user method. And now we should be able to get the user ID by just referring to user.id property. And when it comes to the actual implementation of updating the user, we could obviously create our own repository for the users, but the identity package exposes the iUserStore interface with its concrete implementation, which we can use to update the user and to first of all fetch him from the database. So instead of creating the repository by ourselves, I'm just going to inject the iUserStore object interface, and this class takes the generic parameter of the user definition. So in our case, it's just going to be the user type, and maybe let's just call it user store like this. And as part of the namespace is conflicting with the user type class name, I'll have to either specify a full name, so domain entities.user, or I could just go ahead and adjust the namespace in the user folder to actually be users instead. So let me just first of all change the folder name to users, and then update the namespace to be also users manually for those three remaining classes. Alright, so right now I can just go ahead and add the restaurant domain entities namespace to this folder, and with that I'm able to use the user type as it is no longer conflicting with the user namespace. Now with the user store, maybe let's first of all get this user to some variable, which I'm going to call dbuser, so that the name is not conflicting with the current user from the context. And now on the user store, I'm going to invoke the findById async method, into which I'm going to pass the user ID value. So here again, I'll just pass the user ID as the first parameter, and as the second parameter to this findById async method, I'm going to pass the cancellation token that is available from the handle method. To the findById async method, I will also have to add the await keyword and mark the whole task with the async keyword as well. Right now, I could go ahead and update the properties, so the user nationality to be the value from our request and its nationality property. And in the same way, I can go ahead and update his date of birth to be request.dateofbirth value. But before I will do that, just to make sure that the user is indeed in our database, let's add a simple check. And if the user is a null value, then I'm going to throw a not found exception like we previously did for restaurants and also dishes. So here as the resource type, I'll just specify the name of user type and then its ID, so the user ID value. Lastly, to save the changes on our database context, I will have to invoke the userStore.updateAsync method that's going to take the dbuser object and also the cancellation token. With this simple implementation, let's go back to our identity controller and let's finish the implementation of the update user details endpoint. So I'm just going to pass the update user details comment as the parameter that the clients will send through the body of this request. Then I will have to inject the mediator interface. So let's inject the mediator interface through the primary constructor, and also let's add the base class, which is going to be control base type. Now with this mediator, we can just invoke the send method, to which I'm just going to pass our command, which we can get directly from the HTTP request body. Lastly, back to our client, I'm just going to return no content, so a status code 204. And by the way, this endpoint makes sense only for the authenticated users, because since the request is not authenticated, there is no user context, so there's no point to updating the user who's not logged in. So just to make sure that only the users who are authenticated, I'm going to apply the authorize attribute directly on the update user details endpoint. Alright, let's go ahead and test this endpoint by first of all retrieving the user access token, and then using this endpoint, we should update the user details. So let's run the web application. But before we do that, I'll also have to change the namespace to be restaurants application users for the iUser context and user context types. Now when the error is gone, I can start the web API and open up the Swagger page, in which I will have to first of all authorize my requests. So to do that, let's find the login endpoint, and here I'm going to send the test user credentials, and getting the response, I'm going to just copy the access token, and on the very top of the Swagger page, as you already know, the authorize button can be used to actually input the user context as a bearer token. So now we should be able to actually invoke the patch user endpoint, which can be found here in the identity section. So let's go ahead and execute this request. I'll just provide some sample date of birth and also nationality as Polish, and let's click execute. And in the response body, we are getting 204 no content, and this should mean the user entity should be updated directly on the database. So let's open the database and let's select every record on our ASP.NET users table. And here, as you can see, if I scroll to the very right, we have those two new columns with the date of birth and nationality values, and indeed they are updated with the values provided through Swagger interface. So our patch endpoint works perfectly fine. Maybe the last small refactor that we'll do is strictly connected to Swagger, because at the moment, even though the API endpoints to the identity are the same both for our own identity controller as well as the identity package endpoints, they are separated in those two sections. So maybe just to get those two matched together into the identity section, let's go back for a second to the code. Let me stop the web API, and just to match those two sections into one, here in the program.cs class, on the map group method with which we are adding the identity endpoints, I'm going to also add the with tags method invocation, and I'm going to specify that the tag is going to be identity, and this should align with our own controller. So this time, if I start the web API and go back to the Swagger page, after refreshing, here as you can see in the identity section, now we have every endpoint that is first of all defined by the identity package, and also our custom identity endpoint defined in our controller. So this is how, just by expanding the user definition that inherits from the identity user, we can extend it with some custom properties for which we had to create a database migration, then apply the migration, and also to be able to update the properties through the API endpoints, we had to create a dedicated method which handled the updating mechanism. We have added authentication mechanism to our web API so that we at least know which user is executing a given HTTP request. But what if we would like to restrict the access of some endpoints, for example to create restaurant endpoint just for some dedicated users who are restaurant owners? Or how can we secure the data so that only relevant people can manage it? Well, the answer to these questions and many more is authorization. Authorization is the process of granting or denying access to resources and functionalities within a web application based on the user's identity, role, or permissions. And why is authorization so important? In the ever-evolving landscape of web applications, authorization stands as a crucial pillar, contributing significantly to the overall security, compliance, and user experience. Let's dive into why authorization is so important. In the context of ensuring security, authorization serves as a robust barrier against unauthorized access. By meticulously controlling who can access specific resources or functionalities, it acts as a sentinel, safeguarding sensitive data and preventing potential misuse. A well-implemented authorization system is similar to a digital fortress, fortifying your web application against malicious actors. When it comes to privacy compliance, in the era where data privacy is paramount, authorization plays a key role in ensuring compliance with regulatory standards. By tailoring access to sensitive information based on user roles and permissions, web applications can adhere to data protection laws and build trust among users who are increasingly conscious of how their information is handled. Beyond security and compliance, authorization contributes to crafting a personalized and seamless user experience. By assigning user roles and permissions, web applications can tailor content and features, presenting users with a customized interface that aligns with their needs and responsibilities. This not only enhances user satisfaction, but also boosts overall usability. Let's now talk about the difference method that we can use to decide who can do what in our web apps. The first category is a role-based access control, in short RBAC. Think of RBAC as assigning roles in a play. Each person has a specific role with certain responsibilities. In our web app, users get roles like admin, owner, or a standard user. These roles determine what they are allowed to do. Then there's attribute-based access control, in short ABAC. ABAC is a bit like getting into a club, where they check your ID, age, and other details. In our app, access depends on specific things about the user, like their age, location, or for example, job title. It is a more detailed way to control who gets in where. Lastly, there is going to be a resource-based access control, in short RBAC. Think of RBAC as giving permissions directly to the stuff in your app, like for example files or some restricted resources. Here, instead of focusing on the roles or attributes, RBAC zooms in into specific resources that the users want to interact with. It's like saying only this given user can edit this restaurant. In RBAC, access control is tied to individual resources, making it more fine-grained approach. It's like having a special key for each room in your house. Not everyone gets access to everything. By using RBAC, we can manage access to different parts of our application with precision, ensuring that users only interact with the resources they are supposed to. It adds an extra layer of security and control to our web application. So with that in mind, let's see how can we implement authorization in our web API project. In order to enable role-based authorization, first of all, we'll have to define roles of our system. Let's assume that for this restaurants project, we're going to add 3 different roles: a standard user, a restaurant owner, and also an administrator. So in order to actually insert them to the database, as the identity package have created a ASP.NET Roles table, we'll have to either insert them manually or do it through our seeder. So similarly, as we already did for the sample restaurants, now we can go ahead and create a seeding mechanism for the default roles in the restaurants project. So in the restaurant seeder class, let me also define a separate method that's going to return a collection of the identity role. Let's call it getRoles. And here I'm going to just define 3 different roles that will return in a second from this method. So firstly, let's define a list for the identity role type. And maybe using the collection expression syntax, I'm going to create 3 separate identity roles. Let's go ahead and check out the definition of the identity role. And here, as you can see, we should be able to use the constructor with the role name as a parameter. And this is going to create a new role. It will set the ID property to be a new GUID in a string value. Besides that, the identity role itself will have the normalized name property. And this will be just a uppercase of our name definition. And also a concurrency stamp, which is going to be a unique identifier. So let's go ahead and use the constructor with a single parameter of the role name. So back in our getRoles method, here I'm just going to invoke the new operator, and to the constructor, let's maybe define 3 parameters for user, owner, and also administrator. But with these hard-coded values as the role definition in our system, we'll have to make sure that in every place in which we are going to refer to the system roles, we are keeping the same role syntax. So maybe instead of hard-coding them like this in the role definition, let's go ahead and create some kind of a constant values, so that instead of passing the string value directly, we're just going to refer the constant values on some static class. So now the question is, where should we put the constant values for our user roles definition? Well, if the roles are closely related to our application domain or business logic, we might consider placing the user role class in the domain layer. This is especially relevant if the roles have specific meaning in the context of our application business logic. On the other hand, if some of the roles are more related to infrastructure concerns, then we might put the user roles class in the infrastructure related folders. But in our case, as for example the owner role is going to define the permission to create a new restaurant, this is closely related to our business rules. So maybe in the domain module, I'm going to create a new folder. Let's call it constants. And inside that folder, I'm just going to create a new user roles class. So let's go ahead and remove the unnecessary namespaces. Let's also fix the typo for the constants folder and the namespace. And here I'm just going to create a public static class with the definition of a user role. So first of all, I'm just going to create a public const string value for a user role with the value of user. And similarly, I'm going to create a owner role and also admin role with the value of admin. All right, so having this class defined, now let's go back to our restaurant seeder. And here, instead of hard-coding the role values, I'm just going to refer to the user roles class and now to its constant values of user and then owner, and lastly to user roles admin. All right, so let's go ahead and return this collection from the getRoles method. And now, as we previously did, check whether there are any restaurants in the database. We should be able to check whether there are any roles definition in the DB set provided by the identity DB context. So let's go ahead and create a separate if statement in which I'm going to check whether the DB context dot roles any returns true or not. And if not, it means that there are no roles definition in our ASP.NET Roles table. So in that case, I'm just going to get the roles from the getRoles method, and then on the roles property, I'm going to invoke the addRange method. And lastly, to say that the changes on the database context, I'm just going to invoke the dbcontext.savechangesAsync method. All right, so let's go ahead and start the Web API project. Just to make sure that we are going to insert those 3 new roles, I'm going to put a breakpoint in this if statement. And once the API is up and running, we should hit the breakpoint as there are no roles defined in our table. So firstly, we're going to get the roles and then add them to the database context and invoke the savechangesAsync method. So right now, if I would go directly to the database and select the values from the ASP.NET Roles table definition, as you can see, there are 3 roles for the admin, user, and also owner with their IDs as GUID values. So with that role definition, now maybe let's go ahead and create 3 different users, which then we'll put to the owner, admin, and also a user role. So to create the user, let's go ahead to our API client, and here we can just use the register method to actually create, first of all, 3 standard users, then to which we are going to apply the roles for the admin, user, and also the owner. So maybe I'll just create a admin at test.com. So let's click send request. And as you're getting 200 OK, it means that the admin user has been created. Let's also create a owner test.com. And lastly, a standard user with the same password for all of them. And now if we go back to the database, in the ASP.NET users table, we should have those 3 new users. So for the owner, user, and admin role definition. Now the question is, how to actually assign a user to a given role? Well, to do that, there's a dedicated table with a many-to-many relationship between the user and the role. And this table is called ASP.NET user roles. So here, if I look up the definition, it is just a pair of the user ID and also the role ID as a foreign keys. So we'll have to gather the user ID and also the role ID and just insert that pair to the ASP.NET user roles table. So let me just quickly create the insert statement. We are going to insert into ASP.NET user roles for the columns of user ID and then role ID. So here, first of all, let's get the ID of the standard user and then the owner user. And in a second, we'll also add the role ID as the second parameter to the insert statement. So lastly, I'm just going to grab the admin user ID. And now also, let's go ahead and grab the created role IDs. So first of all, for the user, then for the owner, and lastly for the admin user role ID. So with this insert statement, we are going to create 3 entries into the ASP.NET role table with the connection to a user and a created role. So let's go ahead and run the statement. And right now we have defined 3 user roles for 3 different users to 3 separate roles. But as this table supports a many-to-many relationship, it means that one user can have multiple roles if that would be the case. Alright, so let's go back to our code. And now let's see how can we apply or even enforce the role-based authorization to some of our endpoints, for example, in the restaurants controller. So let's go to the restaurants controller. And here, let's assume that the create method should be available only to the restaurant owners. The first thing that we could check is the user property on any controller. And this property has a method isInRole into which you could pass a role definition as a string value. And this method is going to return a Boolean value, indicating whether the entity, so our user, is in a given role or not. So in case if the user is not in the role, you could just return 403 forbidden status code back to the API client. But instead of that, we should be able to actually use the authorize attribute that we have previously applied on the controller level. And without any additional parameters, it just meant that the user has to be authenticated. There's no additional authorization policy needed for that user. As long as the user has a valid access token, then he was allowed to execute a given method. But right now, if you want to check whether the user has a claim for a given role, we should be able to use the roles property. And here as the string value, we can just define what role allows to execute this given action. So let's just assign the user roles.owner value. And this simple definition of the authorize attribute should now mean that we only allow the owner users to execute this endpoint. So let's go ahead and run the web API and see whether this actually is the case or not. So back to our API client. First of all, let's get the access token for a user that is not in the owner role. So for example, for the admin user. And this admin user shouldn't be allowed to actually execute the create restaurant endpoint. So once I have this user access token, let's also replace it in this token variable. And now if I would try to invoke the create restaurants endpoint with this new access token, so let's add the authorization header with the value of bearer and then the token, then this time, as you can see, we are getting 403 forbidden, even though the user is authenticated and we are putting his token in the authorization header. Just because of that simple authorization attribute definition that we have put on the create restaurant endpoint, we are applying the role-based authorization on this endpoint so that now only the users in the owner role can access this endpoint. So as long as the token information doesn't contain a claim about the owner role definition, it will not allow us to execute this endpoint, and we are just going to get 403 forbidden in the response. Let me also show you what would happen if we didn't even pass the authorization header with the bearer token value. Then in that case, we are going to get 401 unauthorized. So there are two different statuses depending on the authentication first of all, and then on the authorization part. So we can be authenticated as a valid user of the application, but it doesn't mean that that user should have access to a given endpoint based on the authorization policy. Alright, so lastly, let's go ahead and make sure that the user with the owner role is able to actually execute this endpoint with his access token. So right now, let me just log in to the owner user account. Let's grab his access token and let's replace the token variable with this new access token for the user in the owner role. I'm still getting 403 forbidden status code, and this is because the user claims property doesn't contain the information about the user role. Just to make sure of that, I will invoke the get endpoint for a specific restaurant, and here in the controller, if I would look up the user.claims property, as you can see, still we don't have the information about the user role, even though we have actually assigned the user through a database to a given role. And this is because we didn't yet instruct the identity framework to support the identity roles so that they are included in the user claims property. To do that, let me go back to the infrastructure extension method, because here I will have to actually invoke one more method, which is the add roles method. And here as the generic parameter, I'll have to provide the generic base identity role type definition. And now with that method invocation, now the identity framework will also support the role claim in the access token so that our users should properly authorize even to those endpoints which require role-based authorization. So let's start the web API once again and go back to our API client. And this time I'll have to generate a new access token so that it contains the information about the user role claim. So once again, I will log in as the owner user. I will grab his access token. And with that token, if I will just replace it for our variable, we should be able to now execute properly the create restaurant endpoint, which requires authorization for the owner role of our users. And as you can see, now we finally hit the breakpoint inside of the create restaurant method. And this means that our user has been properly authorized for the owner role. If I would look up the user property and his claims, this time there is indeed a new claim with the owner role definition. And just because of this claim, ASP.NET Core Framework will automatically authorize the users for the endpoints on which we have applied the role-based authorization policy. We've seen how to enforce role-based authorization policy and also how to assign user to a specific role directly through the database. But normally, this action should be handled by the application's administrator, so let's go ahead and create an endpoint only for the admin users, which will assign users to a selected role. For this feature, I'm going to create a new endpoint in the identity controller, so maybe let's go ahead and use the already existing one, and let's adjust it a little bit. Here, first of all, let me change the HTTP attribute to be HTTP post, and also I will adjust the path to this endpoint to be user role. Let's also adjust the authorize attribute to only allow administrators. So here with the roles property, I'm going to indicate that only user in the administrator user role should be authorized to execute this endpoint. Let's also change its name to assign user role. And lastly, I'm going to assume that there will be a command called assign user role command. And this command we are going to send through the mediator interface and return no content back to the administrator. So let's go ahead and copy this name and create a new command and also its command handler in our users folder in the application module. But here previously, we already had the update user details command, which was directly in the commands folder, but it should have its own folder. So maybe first of all, let's fix that. So I'll just create a update user details folder first of all, and move the update user details command and also its handler to this new location. Let's adjust the namespaces. And now let's go ahead and create a folder for our assign user role command. And inside I'm going to create the assign user role command class. So this command will have to carry the information about the username or his email and also the desired role into which we would like to assign the user to. So maybe first of all, let's make this class a public, and also let's implement the iRequest interface from mediator. And now let's create two properties. So firstly, I'm going to just add a user email property, and this is not going to be a nullable string. And similarly, we'll have to also store the information about the desired role name. Alright, so let's go ahead and create a command handler just for this purpose. So I'm going to create a class called assign user role command handler. And here, first of all, let's convert this file to a file scope namespace. Let's make this class public, and also let's implement the iRequest handler for our new type, so the assign user role command. Maybe in the handle method, first of all, I'm going to log the information that we are going to assign a user into a specific role. To do that, I will have to inject the iLogger interface for this specific handler. Let's call it logger. And with that logger, now I should be able to invoke the log information method with the message assigning user role. And also we can just pass in the request with the information about the user and the desired role. Alright, now what we have to do is first of all check whether the given user for his email address exists in our database or not. If not, then we are going to return 404 not found by throwing in an exception. And then similarly, we'll have to check whether a given role exists in our database or not. And of course, we could use the user store mechanism that we have seen previously in the update user details command handler, with which we were able to actually get the user by its ID, and similarly we could get the user by his email address. But now, instead of directly using the user store interface, I'm going to inject the user manager, for which I'll have to pass in the generic type of our user. Let's also import the namespace for that type. And with that user manager, I will be also able to get the user by invoking the method find by email async. So here to this method, I'm going to pass the value from our request.userEmail. Let's also make this an asynchronous method. And if the user doesn't exist, I would like to throw the not found exception to return 404 not found back to the API client. So in case if the user is null, then I'm going to just throw a new not found exception, for which I'll have to import the namespace. And here as the type, I'm just going to pass in the user as a string, and also the user address email as the identifier. So here with the null coalescing operator, I'm going to automatically check if the user is null, then I'm going to return a not found exception back to the API client. Now, similarly, we'll have to check whether a given role that we would like to assign the user to exist in our database or not. And for that purpose, I'm going to inject a separate service that is also provided by the identity package. And this one is the role manager, and it takes the identity role as its generic parameter. So here, I'm just going to pass the identity role type. Let's also call this a role manager. So now I will just try to get the role with that role manager. So let me just invoke the find by name async method, into which I'll just pass in the role name coming from our request to this handler. And lastly, I'm just going to throw also a not found exception, but this time for the identity role. And as identifier, I'm just going to pass the request role name value. Alright, so at this stage, we are certain that the user exists in our database, and also the role to which we want to assign the user to exists in its table. So now how can we actually assign the user to a given role? For that purpose, I can also use the user manager object by invoking the addRoleAsync method that takes two parameters. First one will be the user, and the second one is going to be the role that I can get from the role.name value. So let's also await this invocation. And just to get rid of the warning which says that the name might be null here, I'm just going to interact the compiler with the exclamation mark, as we are sure that the role always has its name property with a non-null value. Alright, so let's go back to our controller and finish up the implementation of the new endpoint. So here I'll have to just adjust the usings by adding the namespace for this command. And now we should be actually good to run the API, log in as the administrator user, and try to assign some user to a role and check if it succeeded. So let's start the application. Let's open up the Swagger page. And here, first of all, I will have to log in as the administrator to get the access token, which will allow me to execute the new endpoint. So I'm going to just execute the login endpoint with the admin username and his password. And once this is executed, I will just grab the access token from the response of this body, and I will insert it to the authorizing mechanism of the Swagger UI. Alright, so right now I should be able to actually invoke the new endpoint that's going to create a new user role assignment in our database. So let's go back to the database for a second, because here we only have one user with the username testuser@test.com who currently isn't in any role. So I'll just grab his username, and just to confirm that he is not in any role, let's take a look at his user ID. So the value starts with 457, and if I would select the ASP.NET user roles table, we don't have any assignment for that user to any role. So going back to the Swagger page, I'm going to try this new endpoint for the testuser@test.com, and I'm going to try to assign him to the standard user role. So let's try executing this endpoint, and with this request, I just hit a breakpoint inside of my identity controller. So maybe let's also put a breakpoint in the assign user role command handler. And here, first of all, we are going to log information to the console. Then we are going to fetch the user from the database. And as you can see, the user is properly initialized to the user variable. And then I'm going to get a role based on the request role name for the user. And this, as you can see, actually throw an exception. And if you would look into the console, the message says identity role with the ID user doesn't exist. So let's look up and see what really happened, as the role that we want to assign the user is a null value in our code. And to get that role from the database, the role manager object actually tried to get that role by the normalized name value, which is the uppercase variant of our role name. So here, instead of checking the user role in a camel case, it does it automatically by the normalized name property, which is an uppercase value. But in our case, as we were seeding the roles here in our restaurant seeder, by default the constructor that we have used for the identity role didn't initialize the normalized name property. So if we would go back to the database and actually select the ASP.NET role values, as you can see, there's a null value for the normalized name. So we'll have to fix that in order for the role manager to work properly. So first of all, let me actually fix this data by executing the following update statement. So we are going to update ASP.NET roles table, and I'm just going to set the normalized name to be the result of the upper function for the name column like this. And once I hit run for this command and select all of the ASP.NET roles value once again, Then this time, as you can see, we have fixed the normalized name for our 3 application roles. Let's also fix the seeder so that for any upcoming new database on different environments, this issue will no longer exist. So here, after the constructor invocation, I'm also going to manually assign the normalized name property to be the value of the user roles user to upper, and then for the owner role with the also value to upper, and then lastly for the admin with the value user role.admin to upper. So right now we have manually fixed the database on our local machine, and whenever we are going to deploy this application to a different environment with its own dedicated database, the ASP.NET user roles table should already have the fixed version of the normalized name column for that table. Alright, so let's go ahead and again try to execute the same command through the Swagger interface, and this time we should properly assign the user to its new role. So again, I'm going to execute the same request, and going back to the code, as you can see, we hit the breakpoint in the assign user role endpoint, and moving on, now the role manager was able to properly define the role definition in the database, and lastly with the user manager, we are going to assign the user to this new desired role. So once this is finished, if I would quickly check out the entity framework logs, there is indeed the insert statement to the ASP.NET user roles table with the role ID and also the user ID value. And just to make sure, let's maybe go back to the database and this time select the values from the ASP.NET user roles table. And as you can see, we have a new entry here for our test user whose ID started with the value of 457 to the standard user role. So this is how, by using the built-in classes, user manager and also the role manager from the identity package, we are able to utilize them to provide a feature that assigns the user to a specific role. Maybe lastly, let's go ahead and try to execute the command once again for the same user and the same role, just to see how the user manager is going to behave if we would try to assign a user to a role to which he is already assigned to. So I'm going to execute the same request once again, and this time we'll get the user, we'll get the role, and the user manager didn't actually insert a new user role, as it first of all checked whether a given user is already in the role or not. And since the user is in that role, there's no need to insert the new entry to the ASP.NET users table. And this means that there's no need for us to actually add some additional logic to check whether the user exists in a given role or not. We have introduced a role-based authorization to our system and also enabled administrator to assign and remove roles. Before we'll introduce attribute-based access control, which in our case the attributes for a logged-in user is nothing else but a claim value, let's first of all see how can we extend the default user claims. We know that once we have added this addRoles method invocation, suddenly the role claim appeared in our claims principle, and why is that? To find out, let's take a look at the addRoles implementation and see what is the actual source of the user claims principle values. Well, here in the addRole method, as you can see, one of the services registered to the dependency injection container is the type of user claims principal factory with 2 generic parameters. First one is our user type, and the second is the role type. So in our case, this would be just a user and an identity role types. Now, if you would take a look at the concrete implementation of this user claims principal factory class, it has 2 variants. So the first variant is only expecting 1 generic parameter, which is going to be the identity user. So here, this was the case previously before we introduced the addRole method invocation, and back then, our application underneath used the user claims principal factory just for the identity user without the identity role. And this implementation, if we take a look at the create async method, which actually creates the claims principal, is generating the claims based on the user values, like for example, username, user email, and also some other claims that we have already seen in previous lessons. But then the other implementation of the same class is the one with 2 generic parameters. So here the user claims principal factory expects the generic T-user and also the identity role class. And in this scenario, it's going to actually use the role manager as a dependency, and with that role manager, it's going to extend the base result, which contains the claims with the user email, ID, etc., with one more claim, which is going to represent the role claim type. And then by using the role manager, it's going to find a role and assign a claim to our principal. So right now, we should be able to actually provide our own implementation that's going to inherit from this base user claims principal factory, so that we will not override, but actually extend the claims principal factory. So to do that, I'll just go ahead and copy the name of this class. And in our infrastructure module, I'm going to create a folder called Authorization. And inside, I'm just going to create a class called Restaurants User Claims Principal Factory. And this class will have to inherit from the user claims principal factory for our user and also for the identity role, as we would like to keep also the default implementation with the base claim values. So right now, let's go ahead and create a constructor. Maybe let's make it a primary constructor, which is just going to pass down the values for the user manager, for the role manager, down to the base class of the user claims principal factory. Right now, so here we'll have to just overwrite the create async method, which is going to return the claims principal as a return type. So maybe first of all, let's make sure that under some variable, we are going to store the claims generated by our base class, for which I'll just have to invoke the generate claims async method for our identity user. Now with this claims identity object, we'll be able to invoke the add claim method, which as you can expect, is going to extend the claims principal with some additional claims. So in our case, let's assume that we are going to extend the claims principal with the nationality claim and the user nationality property value, as well as the date of birth, if those two exist in a given identity user. And to do that, first of all, we have to make sure that the user nationality is not a null value. And to the add claim method, I'll have to create a new claim into which I'm going to just pass the type as nationality, and the value is going to be the user.nationality property value. So with this simple implementation, if the nationality property exists in our identity user, this information is going to be stored in the form of a claim and then put into the access token, which we will then retrieve in our controllers to, for example, check if a user has a specified nationality. Now, similarly, I'm going to check if the date of birth property exists on our user. So user date of birth is not a null value. Then in that case, I'm also going to extend the claims principal with the date of birth claim, for which I'll just pass the value of the date of birth property, and maybe with the toString method, I'm going to format this value as a year, then month, and then the day value. Alright, so with this simple implementation, we are going to extend the claims principal with two additional claims for the nationality and the user's date of birth. But if our logic to extend the claims principal will be more complex, I could just simply inject any kind of service or a DB context to this restaurant user claims principal factory class to retrieve the values from the database and then store it as a claim value. Lastly, we'll have to just return the ID object from this create async method, but in the form of a new claims principal object. And for that, you can just use the constructor that's going to take the identity as a parameter. Okay, so having this class defined, now we'll also have to register this class in the dependency injection container so that our own implementation is used instead of the default one that we have seen previously. And to do that, let's go back to the extension method. And here, just right after the add roles method invocation, I'm going to invoke the add claims principal factory method, for which the generic type is going to be our class, so restaurant user claims principal factory type. Right now, this time, if I would log in as a user that has those two properties stored in the database, I should be able to actually see those two claims added to our access token. So let's go ahead and start the web API. And I'm going to log in as the owner who had no date of birth nor the nationality property saved in the database. So let's go ahead and execute the login endpoint and grab his access token, which shouldn't contain the information about the user date of birth nor the nationality. So by placing this token in our authorization header, if I would send some sample request just to see what's behind the user property inside of our controller, here you can see that the identity has 6 claims, but there's no information about the nationality nor about the user date of birth. But once I will log into the application as a user with those two values, which in our case was the user test user at test.com, then for that user, if I would just grab his access token copy its value and also replace it for our authorization header. Then now, if I would send any request to our controller and look up the user property value, here, as you can see, the identity has more claims with our nationality and also the user's date of birth values. So this is how we can extend the default claims principal factory for our application user, just to provide some additional context of the user to the access token in our application. With a custom user claims principal factory class, the nationality and the date of birth claims have been added to our claims principal. Now let's go ahead and see how can we enforce authorization based on the existence or even a certain value of those specific claims. To do that, we'll have to define our custom policy on the authorization builder object, which we can configure through the invocation of the add authorization builder method on the services collection. So being here in the add infrastructural extension, I'm just going to invoke services.add authorization builder, and this method returns an object of type authorization builder. And then on top of that, I can go ahead and invoke the add policy. And with this method, I'm going to be able to actually define a policy, which then you can apply on some of our controllers to actually enforce this kind of authorization. So maybe here, let's go ahead and create the policy that will specify that a given user claims principal will have to have the nationality claim defined. Let's call this policy as a has nationality. So this will be the first parameter. And the second one is an object of type authorization policy. So here, you can go ahead and use the second overload of this method, for which I can just pass in a builder object. And on that builder object, I can just invoke the predefined, for example, require claim method, for which I can just specify the claim type. So our claim has been named nationality. And this will automatically create a policy with the name has nationality, which is going to check whether a claim is principal have the nationality claim defined or not. Now the second step is going to be applying this has nationality policy on a specific controller or on a specific endpoint. So maybe let me grab the has nationality name and go over to the restaurants controller. And here maybe, just for the sake of the demonstration, I'm going to assume that the get by ID endpoint is going to be authorized based on this policy. And in order to actually apply this policy, I'll have to also override the authorize attribute, because now through the constructor of this attribute, I can just specify the policy, and as a value, I'm going to pass in the name of our custom policy. So in this case, it is just has nationality. And with this simple definition of, first of all, defining the custom policy through the authorization builder, and then applying the policy by its name on the endpoint or on the whole controller, now only the users who actually have the nationality claim should be able to invoke this endpoint. And if that wouldn't be the case, they should get 403 forbidden. So maybe to try it out, let's start the web API and see whether this is the case. Alright, so let's go to our API client. And here, first of all, let's grab a token for a user that doesn't have this nationality claim defined. So as we remember, the test user is currently the only user who actually has this nationality claim or the nationality value defined in the database, which then is going to be converted to a claim. So instead of him, I'll just log in as, for example, the owner user who has no nationality. So I'm going to send a request to login as that user. I'm going to grab his access token. And with this access token, once it is replaced as our token variable, now if I would try to go ahead and execute the get endpoint to get a restaurant by its ID, as you can see, I'm going to get 403 forbidden. And this is because this claims principal object that is defined by our access token have no information about the nationality claim. Whereas if I would now log in as the test user who has a nationality, so if I would just grab his token and then replace it as the token parameter, then now in this scenario, if I would execute the same endpoint, as you can see, we are getting a correct response from the same HTTP request, but for a different claims principal context. So now as the claim exists on our principal, I'm able to actually execute this authorized endpoint. So this is how we can apply a simple logic to actually check if a claim exists or not in the HTTP context. But what if the case would be to actually check a given value for a claim? Well, to do that, let's go ahead to the service collection extensions. And here what I can do is actually specify allowed values as the params object as a string type collection. So here I can just specify that not only that the claim has to exist for this given policy, but its value, for example, has to be German, or let's say Polish like this. So now, only the users who have the claim and its value is either German or Polish should be able to actually properly authorize to a given endpoint. So let's go ahead and run the web API to actually verify if this works properly. So if I would execute the same request for a user who has a nationality claim and its value is Polish, then as you can see, still that user is able to actually execute the endpoint with this kind of authorization policy. But just for the sake of demonstration, I'm going to log in once again as the owner user, and for that user, I'm going to update his nationality and also his date of birth values just to check whether this policy actually works based on the value of this nationality claim. So with his token as a parameter, now I should be able to actually invoke the patch user endpoint that's going to update the user nationality and also his date of birth values. So let me just generate this request with the Endpoints Explorer feature. And for that, I will have to also add the authorization header with the value of bearer and then our token as a parameter. And as we remember, the update user details command takes in two parameters, the nationality and the date of birth. So going back to our client, here let's just specify nationality as, for example, French, and then the date of birth as 2010 and the 1st of January. Alright, so after I've sent this request, as I'm getting no content, the user should have now a nationality value, but now I'll have to get the access token once again, because previously the access token didn't contain the information about his nationality. So right now, if I would execute the login for our owner user, then the access token should now contain the information about the user nationality. So I should be able to replace it, and if I would execute the get endpoint for a specific restaurant, I'm again going to get a forward tree forbidden, because even though the claim for the user nationality exists in the claims principal object, the value doesn't match with the allowed ones that we have defined in our custom policy. And just to show that the nationality claim exists on our claims principal object in the HTTP request coming from our API client, let's just add the authorization header to the getAllRestaurants method. And here, if I would send this request and open up the user claims property, then as you can see, the user has 8 claims, and one of them is the nationality claim with a value of French. So even though the nationality claim exists for this user, the value doesn't match with the allowed ones that we have defined on our policy builder. Maybe just lastly, let's go ahead and refactor those hard-coded values. First of all, for the policy name and also the claim names, because now if I made a typo, the policy wouldn't work properly. So let's go ahead and in the infrastructure module to the authorization folder, I'm just going to add a new class, or a new file rather than a class. Let's call it constants. And here I'll just define the public static class of policy names. And as a first public const string value, I'm going to define the value of a has nationality claim name with the has nationality value. Maybe let's also define a similar class that's going to define the names of our custom claims for the application. So for that, I'm just going to copy and paste the definition. Maybe let's call it this time app claim types. And currently we have only 2 custom claims. So first one is going to be the nationality, and the second one is the date of birth. So let's define those two as a public constant values. And lastly, we'll also have to replace the hard-coded values to use one of those 2 classes instead. So maybe first of all, let's go back to our controller. And here, instead of hard-coding the has nationality policy name, I'm just going to refer to the policy names type and then the has nationality. In the same way, I'm going to refer to that value inside of the service collection extension. So here, as the policy name, I'll just define has nationality. And then lastly, the required claim, I will change that hard-coded nationality value to just app claim types dot nationality. And the last place that needs a little bit of refactor is the restaurant user claims principal factory class, because here we also hard-coded the nationality and the date of birth claim types for our claims principal. So here, let's go ahead and also change the hard-coded nationality to just app claim types dot nationality, and similarly, I will do the same for the date of birth claim type. We have configured a custom policy that requires from the users the nationality claim with some specified values. But what if our requirement to authorize based on the claim would be more complex, which would require some more logic? Well, for that purpose, we can create our own custom authorization requirements and define how the authorization logic for a given requirement should be handled. Then for this requirement, we'll just define a custom authorization policy like we did for the has nationality policy. Maybe let's go ahead and add a requirement that will check if a user is at least 20 years old, since we have the access to the date of birth claim value. To do that, maybe I'll just go ahead and start by adding a new policy on our authorization builder. So once again, with the add policy method, I'll have to specify first of all the name of this policy. So maybe for that name, I'll just extend our policy name is static class with one more. Maybe this time let's call it at least 20. So with this simple policy name as a constant value, I should be now able to actually use it through the policy names type and then the at least 20 definition. Alright, and then as the second parameter, let's go ahead and use the builder once again. And this time, instead of using the require claim method, I'll have to invoke the add requirements method. And here as an input, I should be able to actually specify one or many authorization requirements objects. So as you can see, here the parameter is nothing else but the implementation of the authorization requirement interface. So even though there's no method to actually overload for this requirement, we'll have to add a separate definition of the requirement handler. And this is going to be the place in which we are going to put the logic for our requirement. So first of all, we'll have to define a class that's going to implement this marker interface. And this requirement class can also define some additional properties, like for example, the minimum age value for our requirement. So maybe let's go ahead to our authorization folder. And here I'll just create a new subfolder. Let's call it requirements. And inside I'm going to create a class called minimum age requirement. And with this definition, as we already know, I'll have to just implement the marker interface of authorization requirement. And let's make this a file scope namespace. And also let's make this class as a public one. Alright, and here I'll just maybe define a property of type int that's going to define the minimum age for our requirement. So let's go ahead and use the primary constructor to actually assign the minimum age value to our public property. And now to properly handle this requirement, I'll have to also create a separate class that's called maybe minimum age requirement handler. And here I'll have to implement or even inherit from the base class of authorization handler base abstract class, for which as the generic parameter, I'll have to pass in our new minimum age requirement. And this will enforce us to implement the handler requirement asking method. So here, as the parameters, we have two values. First of all is the authorization handler context, and the second one is the object of our own minimum age requirement. The context itself will enable us to actually succeed the authorization policy by invoking one of those methods. So here, as you can see, we can invoke the fail or succeed, depending if the requirement criteria has been met or not. So let's go ahead and try to implement this handler requirement asking method in our own way. So maybe first of all, let's go ahead and inject the iLogger interface, some additional traces from inside the handler requirement asking method. So here, if I actually wanted to use the logger to log in information that a given user is trying to authorize with his date of birth value, then it would be actually good to also inject the user context service in order to first of all get the username and then the user date of birth value from the user claims. So I'm just going to inject the iUserContext object as a reference to our minimum age requirement handler class and use it to get the current user from the HTTP context. So to get the user, I'm just going to invoke the getCurrentUser method on the userContext object. Now maybe let's define a log information that the user with some email and a date of birth with the date of birth value, and maybe the information that we are trying to handle, the minimum age requirement. So here I'll just have to specify the user email as currentUser.email value. And then for the date of birth, we don't have that information yet on our user. So the other option to actually get the date of birth claim value would be to refer to the context And here, as you can see, we have the same property as you have in any controller, that is the claim principal object. So on that object, I should be able to find the claim for which the type is just our own date of birth claim type. But maybe instead of that, let's go ahead and extend our definition of the current user type. So first of all, let's maybe define a null string for the nationality. And then as a data-only value, also with a possible null value, I'm going to specify the date of birth property. So right now, our current user record object is going to contain two more information about the user's nationality and his date of birth. Now, to properly initialize those two values, we'll also have to get them through the user context service class. So here, let's first of all try to get the user nationality by invoking the user find first method. And this time I will have to specify the nationality claim type. And as this is possibly going to return a null value, I'm also going to adjust the operator to check for a possible null. And then similarly, for the date of birth, we'll have to adjust the claim type to date of birth and also parse the value to a date-only type. So maybe first of all, let's get the date of birth as a string value. And as we already know, this might be a null value or a concrete data-only value. So here, for the date of birth, I'm just going to check whether this is a null. And in that case, as a date only, I'm going to assign a null value to our date of birth variable. And if this is not a null value, then I'm going to parse our date of birth as a string value in a specified format, which was year, month, and the day. Alright, so let's go ahead and pass those two values down to our current user object. And now we should be able to actually refer to those two values anywhere just by referring to the iUser context interface as a reference. So going back to our minimum age requirement handler, I'm just going to get the date of birth value as the second parameter from our current user. Right, so now we'll have to check whether the user date of birth value should pass our custom minimum age requirement policy. And to do that, I'll just use the if statement. And here on the current user date of birth property, I'm going to invoke the add years method, into which I'm just going to pass the requirement.minimum age value. And if that value is less or equal than datetime today, which we'll have to convert to the date-only value, and you can do that with date-only.fromDateTime, then this should mean that our user minimum age requirement is properly handled. So maybe here, let's add some log with the log information method and the message authorization succeeded. And to properly indicate to the ASP.NET Core framework that the requirement is succeeded, I'll have to invoke context.succeed method, to which I'll have to pass in our own requirement, just like this. But maybe before this check, as we already know the date of birth value can be a null, so let's go ahead and check. If that would be the case, then we would like to fail this requirement handler as we are not certain about the user age. So if the user date of birth is a null value, then maybe let's log an information or a warning that the user date of birth is null. And here I'm just going to return context fail and also return from this handler requirement asking method. So let me also fix this to check for a null value. Now we should be good. Lastly, let's also fail the authorization requirement if the user's date of birth value doesn't match our own requirement. So in that case, in else statement, I'm just going to invoke context.fail method. Alright, so we have defined our own custom authorization requirement and also its handler. Now, to be able to use it, we'll have to register it on the service collection extension. So going back to our add infrastructure method, this time I'm going to invoke services.addScoped, and here as the iAuthorizationHandler interface, I'm going to register our minimum age requirement handler class. Lastly, let's go ahead and now finally pass our minimum age requirement to the add requirement method for our new policy. So here, let's just define a new object of minimum age requirement, and the value for the minimum age, let's assume that this is going to be 20 for this at least 20 policy. Alright, so let's go ahead and try out this custom policy. So going back to one of our controllers, Maybe this time let's go to the dishes controller, and let's assume that on the get all for restaurant, we are going to apply the authorize attribute with policy name at least 20. And also, as we previously didn't have the authorize method on the dishes controller, I will also apply this attribute without any additional parameters on the whole controller level. Right, so let's go ahead and run the web application and see whether a user that is at least 20 years old can properly authorize to this getAllRestaurant endpoint or not. So let's go to our API client, and first of all, let's create a token for the owner user, for which we previously set the date of birth value to be 2010 1st January. So he's not currently at least 20 years old. So let me just grab his token. And now with this access token, if I will just replace it for the token variable, as we want to try out the getAllDishes for a restaurant endpoint, let's go ahead and add the authorization header to this particular endpoint. Once I will click the send request button, as you can see, I'm getting 403 forbidden. And if I would take a look at the logs, we have the information that the user at test.com with the date of birth value of 1st January 2010 didn't match our own criteria to properly authorize for the minimum age requirement. But let's go ahead and try to execute the same endpoint for a user who should be over than 20 years old. And that user was our first initial test user at test.com. So let's go ahead and grab his access token. I will copy the value of the access token and also replace it for the token variable. Alright, then this time, if I would try to execute the same get endpoint for all dishes in a restaurant, now as you can see, we are getting 200 OK because this user properly passed the authorization requirement which we defined ourselves. If we take a look at the logs, here you can see that the user date of birth value matches our known criteria and the user is at least 20 years old, so the authorization succeeded. Currently, our main restaurant entities can be created only by the users in the owner role. But at the same time, anyone could just delete or update the restaurant details as you are not authorizing the owner access for those endpoints. Before we'll introduce such authorization, first we'll have to store the information about the restaurant's owner. To do that, let's go back to the restaurant entity, and here we'll have to add some properties defining the restaurant owner ID. So maybe I'll just add a new property of type user, and let's call that user as an owner. And for that owner, it would be good to actually store the information about the owner ID, which is going to be represented as a foreign key in our database directly by Entity Framework. So I'll just add one more property of type string, as the type string represents the ID type for our identity user. As you can see, the ID is type of string. So with that type as the owner ID, I'll just specify a new property back in our restaurant class. And also notice that I'm not going to mark the string and also the owner type as nullable values, as we don't want to have a restaurant without its owner. And now you may wonder, what's going to happen to the restaurants that we already have in our database? Well, we'll see in a minute how Entity Framework is going to behave when we are going to apply our new migration to the database. But before we'll do that, let's also jump to the user definition. And here I will just add a definition of the owned restaurants as just a list of restaurants. And let's call this property as owned restaurants. And I will just initialize it as an empty collection with the new collection expression syntax. Alright, so lastly, before we create a migration, it is a good practice to actually configure this relationship through Entity Framework, as we did previously for the restaurant and dishes entities, but now the relationship is going to be the one-to-many. So for a restaurant, it can have only one owner, whereas the owner can obtain multiple restaurants. So back in the onModelCreating method in our restaurants.db context, I'm going to invoke once again the model builder object and then the entity method. And this time we are going to configure the user type. And for that type, I'm just going to invoke hasMany, as the relationship is going to be many to one. And here I can just say that a user has many owned restaurants. And then with one, we are going to indicate that the restaurant can have only one owner. So here to the with one method, as we have the navigation property to a user, which is called owner, I'm just going to indicate that this is the property which Entity Framework should initialize if you would ever try to get the access to the owner from a restaurant entity. Lastly, with the hasForeign key method, I'm going to indicate that the foreign key is on the owner ID property of our restaurant. Alright, so this should be enough when it comes to the configuration of our one-to-many relationship in Entity Framework from the user to the restaurant. Now let's go ahead and execute the update database statement. But before we'll do that, we'll also have to create a migration. So having the package manager console opened, I'm going to type just add migration. Maybe let's call this migration restaurant owner added. So after a while, once the project is successfully built, let's take a look at the created migration. So here, as you can see, Entity Framework is going to first of all add a column with the name owner ID to the table restaurants, and it is not going to be a nullable value. Then it's going to create an index for that new column, and lastly, Entity Framework is going to execute a SQL statement that is going to apply the foreign key from the restaurants table to the ASP.NET users table for the ID property from the owner ID column. And here, as we didn't specify any default value, let's see what will happen when we run the update database statement. So once again, I've just opened the package manager console, and this time let's run the update database command. And after a while, as you can see, we are getting an exception stating that the alter table statement conflicted with the foreign key constraints. And this simply means that we cannot apply a constraint for a foreign key on a column that doesn't contain a proper information about the referenced value. So what we'll have to do is either we could make this owner ID and the owner property as a nullable, but then our migration will have to be adjusted. And this approach would mean that it would be possible to store a null value for the restaurant owner ID column. But in our case, as we would like to always have a restaurant owner, we'll not go with this approach. So instead what we'll have to do is assigning the owner ID column value before the foreign key alter table statement is going to happen. And I can do that through the migration file. So as the column is added after this add column step, down here, before creating the index, and most importantly before adding the foreign key, I can use the migration builder myself and, for example, execute the SQL statement into which I can just pass the plain SQL that will be executed against my database. So here we'll have to update the restaurants table so that the newly created owner ID column has some value, and that value is a ID of a given user. So what could I do is, for example, just insert the following SQL statement. Update restaurants. And here with the set operator, I'm going to assign to the owner ID column some value that is going to represent a given user ID. So I could just go ahead to the database and maybe grab one of the user's ID, copy this value, and then go back to our SQL script. And here, if I wanted to actually specify a given user ID, I would have to insert that user's ID into the SQL statement. The other possible approach would be to actually get his ID from a dynamic select statement. So what I mean by that is here, instead of hard coding the ID value of our owner ID, I could just assign the owner ID column to the result of the following select command. So I would select just top one ID value from the table ASP.NET users. And also, if I wanted to, I could actually add the where statement, for example, check whether the user email is some given value. But as in this example, I don't really care what the user ID is going to be assigned to the owner column. As long as there is any proper value, our script shouldn't fail. So I'm just gonna leave it like this. So update restaurants with the set operator for the owner ID column, and I'm just going to grab the first ID from the ASP.NET user table. Alright, so with this simple adjustment to the migration that has been created by Entity Framework, now if I would open up the package manager console once again and execute the update database command, now this time, as you can see, I'm getting another error as I made a typo here in the ASP.NET user table name, as it should be ASP.NET users with the S at the end. So once again, after executing the update database command, now this time, as you can see, there are no errors here in the console. And if I would go back to the database, let's refresh the restaurants select statement. And here on the right, as you can see, we are getting the owner ID column connected to our owner user from the ASP.NET users table. And if I would look up the restaurant table column, As you can see, the owner ID is indeed a foreign key referencing the ASP.NET Users table. And this would mean that I will not be able to insert any value, but only the values that match the ID of an entity from the ASP.NET Users table. Alright, so let's go back to our code. And the last bit that we are going to adjust is going to be the creation of a new restaurant, because at the moment, if I would try to create a new restaurant, there is no information about the current user who actually created that new restaurant, and still we wouldn't know who is the owner of a newly created restaurant. So let's open up our create restaurant command handler, because this is the place in which we are creating a new restaurant. So as the request represents the newly created restaurant, currently it doesn't contain the information about the owner ID. But the owner ID doesn't have to come from the request, as we can get it from the HTTP context from our API client. So what I can do instead of creating a separate property in the create restaurant command is just referencing the iUser context service and getting the user from the HTTP context. So maybe let me just get the current user by invoking the getCurrentUser method. Maybe let's also adjust the log template to include the user name and maybe his ID. So user ID is creating a new restaurant. So here, let's just first of all pass the current user email as his username. So maybe rather I'll just call this template parameter as a user email instead. And then as the second parameter, I'm going to pass in the user ID property. And then lastly, before we invoke the create method on our restaurant repository, we'll have to assign the restaurant owner ID to the current user ID value. Now with this simple change, let's go ahead and run the web application and try to create a new restaurant from the restaurant owner perspective and see whether actually the information about who created this new restaurant is stored in our database or not. I will open up the Restaurants API HTTP client from Visual Studio, and first of all let's log in as the owner user, as only he will be authorized to create a new restaurant. So let's go ahead and grab his access token, and with that access token, once we'll replace it, we should be able to actually create a new restaurant. Alright, so before we'll execute the post request to /API/restaurants, let's also maybe adjust the name. Let's call this restaurant as an owner restaurant, just to make sure that this is indeed the newly created restaurant. So if I click send request, I'm getting back to one created. And if I would go back to our database and see what was added to the restaurants table, as you can see, we have here a new entry, and the owner ID column has been properly initialized with the value of our owner user. So with the simple adjustment in our entities and then also in the command handler, now we are finally storing the information about the user who actually created the new restaurant. The restaurant has now a property which defines a user who created a given restaurant, or in other words, the restaurant's owner. With this information, we should be finally able to restrict access to a specific restaurant so that only the owners should be able to update the restaurant details. Also, let's assume that both the restaurant owners and the users in the admin role should be able to delete a restaurant. To achieve such resource-based authorization, there are a few different approaches. We could define a custom policy, similarly as we did for the minimum age requirement, but this time its handler would have to know also the context of a resource, so in this case the restaurant, which we want to update or remove. Another approach would be to create our own dedicated attribute, which then you could apply on the endpoint level, and in its implementation we'd have to read the ID of a restaurant resource and check whether given user has access to execute the delete or patch methods. The downside of this approach is that we are restricted to applying the attribute on a controller's endpoint, but sometimes the entry point to our system could be something different, for example a queue message that our application would pick up from a message broker system. For this reason, I'm going to just introduce a custom restaurant authorization service into which I will put all of the logic in the context of modifying the restaurants. Then, if needed to, we could use the service as a reference in our custom attribute or even in the authorization requirement. Nevertheless, the main goal is to have the authorization logic in one place and just reuse it in the handlers which modify the restaurants or delete them. So let's go ahead to our authorization folder in the infrastructure module. And here I'll just create a separate folder for the authorization services. And inside I'm going to create a restaurant authorization service class. And here, let me first of all convert this file to a file scope namespace. Let's make this class as a public. And its only method is going to be the verification whether a given user from the HTTP current context should handle a given resource operation or not. So when it comes to the resource operation, we can create, read, update, or delete the resources. So maybe before we'll introduce the logic in our restaurant authorization service, let's first of all introduce some kind of an enum which will allow us to specify the resource operation. So maybe to the authorization folder, I'll just add a new file. Let's call it resource operation. And this is going to be a public enum with few options. So first of all, create, update, read, and delete. So now with this enum defining the resource operation, let's go back to our authorization service. And here let's create a public method that is going to return a Boolean value. And maybe let's just call it authorize. And into this method, I'll have to pass in first of all the restaurant resource. So as a restaurant, I'll just pass the first parameter. And as the second one, we'll have to also define the resource operation type as our enum value. Now we'll have to get the user from the HTTP current context and then check our authorization logic for a given resource. But maybe first of all, let me inject the iLogger interface so that we'll have some visibility inside of this authorization service. Besides the logger, I'll also inject the iUser context service because we will need the current user context inside of the authorization method. So here, let's maybe first of all grab the user as a result of the user context, get current user method, and now maybe with the logger, let's add some information as follows. Let's say authorizing user and then his user email, let's say to, then the operation for restaurant. And let's assume that we are going to pass the restaurant name as the third template parameter. So let's go ahead and first of all pass the user.email value. Then we are going to pass the operation and lastly the restaurant name. So the second parameter is going to be the restaurant operation value. And lastly, I'll just pass restaurant.name property. Alright, so after this block, we can now finally define our custom logic to authorize user to a given restaurant in the context of a given operation. So maybe let's start with the simplest one. So for the create and read, there shouldn't be any restrictions. So let's say the resource operation is equal to read or the resource operation is equal to create. Then in that case, maybe let's just log the information that this is a create or read operation and there are no additional checks for the authorization create or read a given restaurant. So I'll just return a true from this authorize method. Then our second check is going to be the delete operation. So here, as I mentioned before, we'll want to allow the restaurant owner as well as the administrator to be able to actually delete the restaurant. Here, maybe first of all, let's check if the resource operation is in fact delete. Then also, I'm going to invoke the isInRole method on our user to check if the user is in the admin role. And in that case, I'm just going to log an information that this case is for admin user and the delete operation. So there is a successful authorization. Let's go ahead and return true value. Lastly, we'll have to check whether the resource operation is equal to delete or update. And at the same time, we want to check if the given user is the actual owner for a given restaurant. And to check that, I'll have to also include the second part of this if statement, in which I'll just check if the user.id value is equal to restaurant owner ID property. So in this case, it's the owner restaurant, and also we are going to successfully authorize him to delete or update the restaurant. Let me also fix the second operation type. It was supposed to be update, not create. Alright, and then finally, if the current user didn't match any of those three checks, then it means that he shouldn't have the access for a given resource operation in the context of our restaurant. For him, we are just going to return a false value from this restaurant authorization service. Now maybe let's also extract an interface for this restaurant authorization service. I'll add it to new file, and with that interface, we'll have to now also register the restaurant authorization service in our dependency injection container. Let's go to the extensions, and here I'm just going to invoke services, add as a scope dependency for the iRestaurant authorization service. I'll just register the restaurant authorization service concrete type. Now we should be actually able to use the iRestaurant authorization service interface as a reference in our handlers to properly authorize given user in the context of our restaurant. But if you would go to, for example, the delete restaurant command handler, and if I would wanted to actually inject a reference to the restaurant authorization service object, then as you can see, I'm not able to actually refer to the infrastructure module because our application module has no reference to the infra layer. And in this kind of scenarios, in which we want to use a reference from the infrastructure layer in our application layer, the case is very similar as we had previously with our repositories. So previously, we just added the interface for our repository inside of the domain layer, and we have registered the concrete implementation in the infrastructure module instead. And this will be the same approach now for the authorization service. So let me just quickly grab the restaurant authorization service interface. I'll just, first of all, maybe create a new folder. Let's call it interfaces in the domain module. And to that folder, I'll just cut the file with our restaurant authorization service. I will also adjust the namespace. And lastly, we'll have to also bring the resource operation reference also to the domain layer, as we are using that as a reference. So let me also grab the resource operation file. I'll just cut it and paste it to the constants folder in the domain module. And for this file, I'm going to also change the namespace to match the folder structure. And now we should be able to finally reference the resource operation from the iRestaurant authorization service. And coming back to our service collection extensions, without any change, we still should be able to register the iRestaurant authorization service as its concrete implementation. With this simple change, if we would go back to the restaurant command handler, there is no longer a problem to actually inject the iRestaurant authorization service to this concrete delete restaurant command handler. Now we can use that reference and check if the authorize method invocation returns a false value for a given restaurant and the operation type delete in this concrete handler. So if that will be the case, it means that a given user shouldn't have access to complete this command handler implementation. And to such user, we would like to return also 403 forbidden status code. And for that purpose, I'm just going to throw a new exception. Let's call it just forbid exception, which we are going to just add in a second, and then also adjust our custom exception middleware to catch this type of exception and then return 403 forbidden back to the API client. Let's go ahead and create this exception type in our exceptions folder. So right here in the domain module, we had this exceptions folder, in which I'll just create a new forbid exception. And let's make this class public and just inherit from the base exception type. So with that in place, now we should be able to throw the forbid exception anywhere where the user shouldn't be authorized to perform a given action for a restaurant. So I'll just grab the same piece of code and also add it to the update restaurant command handler. So here, right after checking if the restaurant is a null value or not, I'm also going to check whether the user should be authorized to perform the update operation by first of all injecting the iRestaurant authorization service. And then on top of that, I'll also adjust the resource operation to be update as we are in the update restaurants command handler. Also, if you would think about it, adding or removing dishes from a restaurant is some sort of updating the restaurant details. So maybe I'll just grab the same piece of code and go over to the dishes commands. And first of all, let's adjust the delete dishes for restaurants command handler. And in here, I will again check whether we want to update the restaurant resource and if the current user should have access to that or not. So let me just also inject the iRestaurant authorization service. And the last place is going to be creating a dish for a given restaurant. So once again, I've just added a bit of code to check whether the current user can update the restaurant details by creating a new dish for a given restaurant or not. So let me just inject the iRestaurant authorization service, and that should be it. But the last step will be now to handle actually the forbid exception inside of our error handling middleware. So let's go back to the error handling middleware. And in here, before we'll catch the general exception, let's also insert one more catch block in which I'm just going to catch the forbid exception And in that case, I'm just going to return 403 forbidden, and maybe as the message, let's just say access forbidden. Alright, and this should be it. Now let's go ahead and try to start the application and execute the update restaurant details command through a user who is an administrator or the restaurant owner and see whether they are able or not to perform given action, and then we'll do the same for the delete endpoint. So let me start the web API. Let's open up the API client through Visual Studio, and first of all, maybe let's log in as the administrator who should be able to delete but not update the restaurant details. So let me just grab the admin@test.com access token. And with this access token, if I would just go ahead and replace it as our variable, let's try invoking the getAllRestaurant first of all, just to grab some ID for a given restaurant. So let's assume that I would like to update and then delete the restaurant with ID 1010. So let me grab this ID and head over to the HTTP patch request, for which I'll just change the name to be updated name like this. And as an administrator, if I click send request, I'm going to get first of all unauthorized, since we are not including the token in the authorization header. So let me just include the bearer and the token value in the authorization header. And this time, if I send that request, we are getting 403 forbidden, access forbidden in the response body back to the API client. And this is because even though we are an admin user, the logic that we have defined in the restaurant authorization service doesn't allow an admin user to actually update properties of an existing restaurant. But if I would try to remove such restaurant as an admin user, then in that case, if I would just include the bearer token in such a request for the same restaurant, so the one with ID 1010, if I click send request, as you can see, we are getting no content back to the API client. And this means that admin user has been successfully authorized to perform the delete operation for a given restaurant. So just to make sure, if I would also get all restaurants that exist in the database, as you can see, the one with ID 1010 no longer exists. Lastly, just to confirm that the owner of a given restaurant can still edit that restaurant details, let's go ahead and get the access token for the owner user by changing the email and sending the login request once again. Now with his access token, we should be able to not only perform the delete operation, but also the update with the restaurant details. So with his token replaced, let's try to modify a restaurant now with a different ID, since we have removed the one with 1010. So now the ID should be, for example, 1009 in my example. And if I would send that request, as you can see, the owner of this restaurant is getting 204 no content. Just to make sure, let me also invoke the endpoint to get the restaurant details. And as a result, there's indeed the new updated name for this given restaurant. Also, as the owner user for a given restaurant, I should be able to delete a given restaurant in the same way as the administrator of the application did previously. Just to make sure of that, let's go back to the delete endpoint, but this time also we'll have to adjust the ID of that restaurant. And if I would click send request, we are getting 204 no content, and this means that there is no longer the restaurant with ID 1009, as we just did remove it as the owner user for that restaurant. So this is how, by introducing some kind of a service with our custom logic to perform a given operation on our restaurant users, we'll be able to actually use the authorize method in any place in which we would like to perform such operation in the context of a given user.